this video, we will solve some numerical problems related to area under the curve of motion. But before starting numerical problems, let's recall some previous information related to graph of motion. The distance time graph of a body can be used to calculate the speed of the body, or the slope of a distance time graph indicates speed, and the slope of velocity time graph indicates acceleration, and area under the graph represents displacement of a body. In displacement time graph, slope is equal to displacement upon time is equal to meter per second, which is equal to velocity. If displacement is constant, then the velocity is zero. In second graph, when a body moves with uniform speed, it will travel equal distance in equal interval of time. It means the distance traveled is directly proportional to time. So the graph will be a straight line. If v increases rapidly, then the larger increment in displacement, and if velocity decreases, the smaller increment in displacement. If velocity decreases uniformly, then s decreases uniformly and object moves at opposite direction. Next is velocity time graph. The slope of a speed time graph of a moving body gives its acceleration. Acceleration is equal to change in velocity divided by change in time. Slope or gradient is equal to final velocity minus initial velocity divided by time. And the area under the velocity time graphs gives us the displacement. In case of uniform acceleration, the area under the graph is equal to triangle area, that is equal to 1 upon 2 base into height, and base is time and height is velocity. We can put the units of velocity as well as time, and we will get the unit of displacement, which is meter. And if the graph of velocity time is rectangle, so the area under the graph is equal to rectangle area, which is length into breadth. Let us take first example. Find the distance covered by a particle during the time interval t is equal to 0 to t is equal to 20 seconds, for which the time speed graph is shown in figure. These are the options. Simply we will draw the points and we get a straight line. This is the example of uniform acceleration, but we have to find the distance covered by a particle. So the distance is equal to area under the VT graph is equal to 1 upon 2 base into height. Base is time and height is velocity, that is equal to 1 upon 2 into 20 second into 20 meter per second. This is equal to 200 meter. So the option B is correct. Next question is, the displacement time graph for two particles A and B are straight line inclined at angle of 30 degree and 60 degree. With the time axis, the ratio of velocities of VA raised to VB is. Next question is, the displacement time graph for two particles A and B are a straight line inclined at angle of 30 degree and 60 degree with the time axis. The ratio of velocities of VA raised to VB is. We know that the slope of displacement time graph is velocity, or tan theta is equal to y axis divided by x axis. So the velocity of A particle is equal to tan 30 degree and velocity of B is equal to tan 60 degree. So the ratio is tan 30 degree raised to 10 raised to 60, and the value of tan 30 degree is equal to 1 upon root 3 and value of tan 60 degree is equal to root 3. So the ratio will become 1 upon root 3 raised to root 3, which is equal to 1 raised to 3. So the option D is correct answer. Next question is, figure shows the speed time graph of a particle. Find the distance traveled in the time interval 0 to 40 seconds. Next question, figure shows the speed time graph of a particle. Find the distance traveled in the time interval 0 to 40 seconds. The slope of speed time graph gives us a quantity acceleration. First of all, we will divide this graph into three sections. First is OE, second is ED, and third is DC. OE section represent the uniform acceleration, and ED section represent the zero acceleration, and DC represent the retardation. but we have to find the distance. So the distance is equal to area under the VT graph. Again, we will divide into three parts. First is triangle OEA, and second area of rectangle AEDB plus area of the triangle BCD. So the total area is equal to area of the triangle OAE plus area of the rectangle ABDE plus area of the triangle BCD. In triangle OEA, area is equal to 1 upon 2 base into height. 1 upon 2 into 10 meter per second is equal to 50 meter. In the rectangle ABDE, the area of rectangle ABD is equal to AE into AB, equal to 10 meter per second into 20 second is equal to 200 meter. In section 3, the area of the triangle BCD is equal to 1 upon 2 base into height is equal to 1 upon 2 into 10 into 10. Area is equal to 50 meter. So the total area is equal to A1 plus A2 plus A3, which is equal to 50 meter plus 200 meter plus 50 meter is equal to 300 meter. So the distance covered by the particle is equal to 300 meter. So the option C is right answer. Next question is, a person walks along the sides of a square field. Each side of each side is 100 meter long. What is the maximum magnitude of displacement of the person in any time interval? In square, we know the all sides are equal and displacement is the shortest distance between any two consecutive points. So the maximum displacement is along the diagonal of the field. S max is equal to, applying Pythagoras theorem, root of 100 square plus 100 square is equal to 100 root 2, and put the value of root 2 is equal to 1.414.